One of the most common everyday applications of Bernoulli's principle is in air flight. In an airplane wing, the top of the wing is somewhat curved, while the bottom of the wing is totally flat. In the sky, air travels across both the top and the bottom concurrently. Because both the top part and the bottom part of the plane are designed differently, this allows for the air on the bottom to move slower, which creates more pressure on the bottom, and allows for the air on the top to move faster, which creates less pressure. This is what creates lift, which allows planes to fly. Baseball is an example of where Bernoulli's principle is very visible in everyday life, but rarely do most people actually take note of it. One example in baseball is in the case of the curved ball. This allows for friction to cause a thin layer of air to engulf the misunderstanding of the baseball as it is spinning. But since the ball is spinning in a certain manner, this allows for more air pressure on the top of the ball and less air pressure on the bottom of the ball. Therefore, according to Bernoulli's principle, there should be less speed on the top of the ball than there is on the bottom. So, the bottom part of the ball accelerates downwards faster than the top part.
Lady golfers are in town all this week. Imagination Station has an experiment that's sort of geared toward that event. It has to do with floating balls. For more of an explanation, Jeff Stevenson is here with the Bernoulli blower.
Exactly.
Jeff, good morning to you.
Good morning to you. What we have today is we have kind of some really cool air science. So we're going to be talking all about air today. So to get started, I have this very, very long bag. Why don't you go ahead and take that in? Okay. I'm going to unroll it. And it's 8 feet long and holds about 45 liters of air. Now I have a question for you, Chris. How many breaths do you think it would take for you to fill up all 45 liters of this bag?
Is this like the Tootsie Pop question?
Not quite.
Okay, I'm going to say more than 3 then.
More than 3? Well, let's give 3 a shot. Let's take
boy.
big deep breaths. 1, 2, 3, and let's see how far you got. Oh, Chris, not so great, not so great.
Take me a few more.
It might take you a few more than that. What if I told you I could fill this whole thing up in 1 breath?
I wouldn't believe you.
Well, we're going to use kind of a nice principle of science. Why don't you hold on to that end for me?
Okay.
I'm going to step back. I'm going to hold this bag away from me, and I'm going to create some moving air on the inside of it. So
okay.
Here we go. 1, 2, 3. And I can actually fill up the entire bag.
Making me look silly, Jeff.
Well, I'm not trying to make you look silly. I'm just trying to use an effect called the Bernoulli principle.
That was actually really cool.
Yeah. Well, all I did is I had some moving air on the inside of this bag, and since it was moving, it's lower pressure. And the low pressure air on the inside wanted to even out with the high pressure air on the outside, and so all the high pressure air came on in, because I don't have 45 liters of air in my lungs.
I took some pretty hefty breaths of air into that, and I didn't even come close.
Yeah, exactly. So let's go ahead and get rid of this thing for now. We'll just throw that off there. Now, we kind of have another demonstration of the Bernoulli principle. I have a hair dryer. You can have one of these at home, and I'm going to go ahead and give you a plastic golf ball for our Marathon Classic this coming weekend.
Okay.
So why don't we go ahead, and I'm going to turn this on and just place that in my hair dryer.
All right.
And go ahead and let go. Whoop. Maybe this golf ball, as you can see, it is actually staying afloat. And don't worry about that, I got tons of them here. And that's because the moving air on the bottom is creating low pressure, and the high pressure air has to come underneath of it, and it's kind of like an airplane, keeping it aloft. Low pressure on the bottom helps keep it aloft. So we'll go ahead, and that's pretty interesting. You could do that at home. But at Imagination Station, we like to do things on a bigger scale.
Of course.
Of course, like I'm sure you know. So what I brought today is I brought a leaf blower, all right, as our hair dryer. And I'm going to give you a nice plastic baseball, a little bit bigger than a normal baseball. And I'm going to turn this on, and you're just going to place it right on top. So why don't you go ahead and do that for me now. Now that's pretty cool, but I brought even a bigger baseball. So why don't you go ahead and get rid of that and grab that one behind you for me, would you? We're going to try this again on an even bigger scale, because once again, we're at Imagination Station. We don't do things small here.
Right.
All right, here we go. Go ahead and run your hand through there. Pretty cool, right?
No strings attached.
No strings attached.
Very
now,
cool.
The Bernoulli principle can be used for airplanes, like I said. So what you can do is if you take like a piece of paper and you go ahead and just blow across the top of it, you'll see that you're creating low pressure on top, high pressure on the bottom, which is pretty cool, but on this little wimpy piece of paper, it's not very interesting. So what I'm going to do is I'm actually going to hand you the leaf blower now.
All right.
All right. And you have a switch right here. And I'm going to go ahead and take this toilet paper, and just like how you blew across this paper to create low pressure on top, I'm going to have you blow across my toilet paper.
Okay.
All right? And we're going to create low pressure on top, and we're going to see if we can't burn through this whole roll of toilet paper very, very quickly.
You're not teaching kids how to TP the neighborhood.
I would never teach kids how to TP the neighborhood.
Good.
This is strictly for scientific
Just science
purposes.
here.
Just for science. So I'll go ahead and hold on to it, and when you can flick that switch, and you're going to blow it right across.
Okay. Ready?
Yep.